Welcome Algebra 2, this is section 4.2, standard form of a quadratic function. The essential question is, what key information can you determine from a standard form quadratic function? Let's begin. So this lesson is about the standard form for quadratic functions. We did vertex form last time. So what key features are in standard form? Well, there's a lot of the same ones from vertex form. So for example, that a coefficient for the x squared, it still stretches and compresses the graph, just like with vertex form. It still reflects the graph, just like vertex form. Here's one difference though. How do you find the vertex for a standard form function? And the key formula here, the vertex, the x-coordinate of the vertex is going to be negative b over 2a. So for example, in this case, if my a would be the 2, my b is the 4, and my c is the 3, my vertex in this case is going to be negative 4 divided by 2 times 2, which simplifies to negative 4 over 4, which is negative 1. That's the x value of the vertex. To find the y value, to find the y coordinate, I got to substitute that x coordinate into the equation. So substituting into here, my y equals 2 times negative 1 squared plus 4 times negative 1 plus 3. And that's going to be 2 times 1, so just 2 plus minus 4 plus 3. 2 minus 4 is going to be negative 2, so negative 2 plus 3. And that comes out to positive 1. So my x coordinate is 1, negative 1. My y coordinate is positive 1. So that makes sense because the coordinate of this vertex right here is negative 1, positive 1. So that's how you figure it out. A little bit more math. Just can't look. The axis of symmetry is also a little different. The equation for the line of the axis of symmetry is just x equals the x coordinate, negative b over 2a. So in this case, we figured out negative b over 2a was negative 1. So the axis of symmetry is x equals negative 1, and that's a straight up and down line at negative 1. Standard form. To find the y-intercept of a standard form equation, it's just the c value right here. So 0, c is the coordinates. In this case, our c value is 3. So my y-intercept is this point right here, 0, 3. All right, what else? That's it. Those are all the neat things. So let's get started. Pause the video. Alright, graphing. And it's similar to how we graphed last time. That's why I didn't put steps into this. The first thing I got to figure out is the vertex. So what's the vertex in this case? Well, the x-coordinate is going to be, well, let's figure out what my a, b, c is. My a is 1, my b equals 2, and my c equals 3. So my x-coordinate is going to be negative b, so negative 2 over 2a, 2 times 1, which is negative 2 over 2, which is going to be negative 1. If negative 1 is my x-coordinate, figure out what the y-coordinate is. I'm going to substitute that in. So y equals negative 1 squared plus 2 times negative 1 plus 3, which is going to be 1 minus 2 plus 3, which is going to be 1 minus 2 is negative 1 plus 3, which is going to be positive 2. So my vertex is at negative 1, 2. I'm going to plot that point, negative 1, 2. Put a vertex right there and label it. Now I found the vertex, I got to write my axis of symmetry. The axis of symmetry, AOS, is going to be at x equals whatever the x value was, negative 1. So I'm going to do a dashed line at x equals negative 1, so I know where to mirror. Okay, axis of symmetry is in. So let's figure out some more points. And I'm going to make an xy table right here. I know my first point, the vertex, is negative 1, 2. Now I'm just going to pick 2 points to, let's say, I don't know, let's do it to the right. 0 and 1, because those will be probably pretty easy. So if I plug in 0 for x, I get y equals 0 squared plus 2 times 0 plus 3, and that's just going to be 3, because these cancel out. So y is 3. Now for x equals 1, you get y equals 1 squared plus 2 times 1 plus 3, which is going to be 1 plus 2 plus 3, which is 6. So my y value would be 6. I'm going to plot those points. 0, 3 happens right here. I'm going to label it 0, 3. 1, 6 happens up here. I'm going to label it 1, 6. And now the next step is I got to mirror those points on over the axis of symmetry. So this point would be 1 to the left up here. I'll label that negative 2, 3. And this will be 2 to the left over here. And label that negative 3, 6. Now that I have those 5 points, I draw my perfectly straight or perfectly curved parabola. Oh boy, that's pretty bad. Let's try that again. Not bad. Better than usual. And that's it for that. Pause the video. Okay, so it's asking what's the vertex form equation for this. So right now I'm in standard form, and I want to convert it to vertex form. And vertex form is y equals a times x minus h squared plus k. Well, all we have to do is figure out what my three unknowns are. A equals, h equals, and k equals. Well, my a is going to be the same a as for the standard form, so a is going to be -1. Well, what's my h and my k? Well, my h is the x value of the x coordinate of the vertex, right? And that's going to be a formula. H is going to be -b over 2a. So in this case, it'll be -4 over 2 times -1, which is -4 over -2, which is going to be +2. So my h equals +2. Now to figure out the k, you just got to plug in the x coordinate of the vertex, and the k is the y coordinate of the vertex. So in this case, I'm going to write k equals -2 squared plus 4 times 2 minus 5. Careful with that negative sign because the negative's not being squared. So it comes out to -4 plus 8 minus 5, which comes out to, that's 4 minus 5, which is going to be -1. So my k is -1. Now I have all the key parts there, I can just plug it in. The vertex form is going to be y equals a, so negative quantity x minus h minus 2 squared plus k, or -1. That is the vertex form. That's it.